Assalamu alaikum. I'm Munami Sharmita Azad, ID 16201039. I'm from CSE425 Section 2. Today I'm going to give my one-to-one presentation of neural networks, and my topic is generalization. Welcome to my presentation today. Today we are going to talk about generalization in neural networks. Generalization is one of the most important topics in neural networks. So today we are going to discuss how generalization works. So to begin with, we have to discuss what generalization is. So generalization refers to the model's ability to adapt to new and previously unseen data drawn from the same distribution as the one used to create the models. So here, firstly, we have to learn from a dataset, and then from this learning, we have to determine the test dataset. So in other words, what we can say is generalization is the process of generalizing the data it has not seen before through a learning process from the training dataset. So, moving on from here to the next point, we are going to talk about the subsets of generalization. The generalization process can be divided into three subsets. So, now let's talk about these three different subsets. So, the first of these three sets is a training set. So, what is a training set? A training set is a set of training examples that the network is trained on. So here, firstly, our system has to learn from the training dataset, then the system has to validate the dataset, and then the system has to implement the learning to the test datasets. So let's move to our next slide. So moving on from here, we're going to talk about overfitting. So what is overfitting? Overfitting is a phenomenon in neural networks. To be more precise, when an algorithm refuses to determine the resulted outcome from the test dataset by observing a test dataset, then it is considered that this neural network has overfitted on the training data. When a system cannot determine or cannot understand the test dataset from a testing dataset, after testing and validating data, then we can say that our data has been overfitted. The main goal of generalization is to reduce this overfitting. So now moving on to the next point, which is methods of generalization improvement. So how can we improve the generalization process? What are the methods that we need to follow to improve our generalization process? This is divided into three parts. Firstly, regularization, then early stopping, and then retraining neural networks. So, what is regularization? Regularization is any modification to a learning algorithm to reduce its generalization error but not its training error. So, when we have to think about reducing the generalization error, we have to think that we do not have to reduce the training error. So, then we have to focus on reducing the generalization error even at the expense of the increasing training error. The limiting model capacity is an example of the regularization method. So firstly, what we can see in this figure is that this is divided into two parts. That is, in the y-axis, we can see the error, and in the x-axis we can see the optimal capacity. So in this curve, this is basically the underfitting zone, and this is the overfitting zone, and this is the generalization gap, and these blue dotted lines are the training error, and this green line shows the generalization error. So, without further ado, let's move to the next slide. So, the next slide contains the goals of regularization. So, what are the goals of regularization? Some of the goals of regularization are: 1. To encode prior knowledge. 2. To express preference for a simpler model. 3. The need to make the underdetermined problem determined. So basically, what regularization has to accomplish here is that essentially the problems that are underdetermined, the regularization has to work to make those problems determined. So these are the goals of regularization. So now we're going to move to our next slide, which is early stopping. So how do we define early stopping? Early stopping is a regularization technique for deep neural networks that stops training when parameter updates no longer and begin to yield improvements on a validation set. In essence, we store and update the current best parameters during training, and when the parameters update no longer and yield an improvement, basically after a set number of iterations, we stop training and use the last best parameters. It works as a regularizer by restricting the optimization procedure to a smaller volume of parameter space. Now let's look into the figure of early stopping. So from what we can see in the diagram of early stopping is that this curve shows the validation set and this shows the training set. So from the training set, we have to figure out where to stop, and here we are not going to work with all the training set because we have to validate the training data set. Then we have to implement it to our validation set. So this is our validation set. From the training data set, we have to determine the validation set. So essentially, this is the concept of early stopping, where we have to validate our data from our training dataset by early stopping. So we have reached the last part of our presentation, and last but not the least, we are going to talk about retraining neural networks. So what do we essentially mean by retraining a neural network? So basically, retraining of a neural network model is to cope with the continuous flow of new data and inference during model serving. As such, this is a lifelong learning process. We address two challenges of a lifelong retraining: catastrophic forgetting and efficient retraining. Typically, each backpropagation training session starts with different initial weights and biases, and different divisions of data into training, validation, and test sets. These different conditions can lead to very different solutions for the same problem. Finally, to sum up, we can say that following this process, we are going to get a generalized data and we can relate with the real world through our system. So that was all about generalization in neural networks from me, and I'm going to wrap up my presentation here. Thank you.